As the first step on our journey to making our ArrayMap class iterable, we're going to do this little puzzle here. So the code on the left is the for each loop, and on the right, the equivalent code if we were to expand it out. So let's consider this question. For the code on the right to work, what is it that the compiler needs to do? So there are 4 possible things the compiler might need to do in order to feel okay with this code, and your job now is to play compiler and figure out what you think. So I'll wait here. Okay, giving you a whole minute. Though you have to pause. All right, because you don't want to watch you with my eyes closed for a minute. So this code right here, the first thing we might ask is, for this first call, what happens? Well, friends.iterator gets called. What's the static type of friends? It seems to be a list. So if we have a list.iterator, we have to check to see if the list interface has an iterator method. Okay. How about next? Here we have seer.hasNext. What's the static type of seer? Well, seer is an iterator of integers. And so we say, do iterators have a next method? And do iterators have a hasNext method? Both of these things happen. So the answer is that we need to check A and we need to check D. So essentially, for this code to work, 2 things need to be true. The compiler has to check that the list has a method called iterator that returns an iterator of integers. Otherwise, this won't compile. And we also need the compiler to check that an iterator has these two methods. Okay. So how does this really work under the hood? Well, whenever the compiler, the way it knows that lists have this iterator method is that it turns out that lists actually extend an interface called iterable. What does that iterable interface say? It says you must have a method called iterator that returns an iterator. Okay. So in that sense, this is the declaration. The fact that we extends iterable, this is the declaration that makes Java perfectly okay with this first check. And then the second one comes from the fact that the iterator interface, it consists of at least 2 methods. I'm only showing 2. There's actually more. It has at least these 2 methods that, as a result of these existing in this interface, an iterator, of course, will have any iterator you might make will definitely have a hasNext and next method. Okay. So in other words, this ensures the first check, this ensures the second. So what we're going to do now then is actually go through and implement this thing to make sure all that made sense. And what I'm going to do is I'm going to start, so this is going to be ArrayMap.java and IterationDemo.java, and we're going to create a key iterator class that will allow us to go through and do things the hard way first. So by the hard way, I mean the following. Let's go into our code here. This is iteration demo. It creates an array map. And then what it's going to do is instantiate an iterator. It's going to use hasNext and next in order to print things out. And eventually we'll get to the point of doing things the easy way instead of the hard way. Now, when we first start this off, it yells at us and it says, I don't know what a key iterator is, what hasNext, what next is. And the issue is we need to go to ArrayMap and make it so that it has a nested class called key iterator so that we can instantiate it. And we'll get to this funny syntax in a bit. So I go to ArrayMap and I say, okay, well, it looks like I need to have some kind of inner class or nested class called key iterator. So I'll say public class key iterator. Okay. So now that I've done that, we go to iteration demo and we see that this is no longer red. There exists something called key iterator. However, there's no hasNext or next method in key iterator. So what it's basically saying is that's something that's missing from this nested class. So we also need a public Boolean hasNext. And we also need a public k next method. And so now that we've done this, we actually need to return something, otherwise it won't compile. So we return false, we return null, and that gives me a key iterator. Okay. So we go back to iteration demo, and now we see that everything compiles just fine. We've satisfied the compiler, and now if we run it, not a lot's going to happen. It does nothing. And that's no surprise because ami.hasNext is going to be false. Now I'll address this funny syntax right here. The reason it's am.newKeyIterator and not just newKeyIterator is that the key iterator class, it needs to be associated with a specific array map. So it wouldn't make any sense to make a key iterator that wasn't part of a specific array map because it's going to do the role of that wizard. It walks through a specific array. You can't make it on its own. So instead, we have to go to a specific array map and say, hey buddy, go make me a key iterator. And at that point, things will be okay. So this is a new syntax we haven't seen before. You don't often see it, But if you want to instantiate a nested class that is not static, you use an instance name before the word new. Okay, so let's go on to writing our key iterator. If we want to go and basically play the wizard's game, the wizard stepping through the array, one step by one step, we need to keep track of the wizard's position somehow. This being an array, it makes sense to store the position as an integer. So we might call this something like wizard position or something. We also then probably need a constructor to set that. I mean, it seems natural. We don't have to, but I'll do it. I mean, what I mean by we don't have to, we could just say equals 0 up here. But I'm going to make this thing here set in the constructor, just because. And so here we've created or set the wizard position to 0. And now what we're going to do is set up the iterator so that it does the right stuff. So imagine that the wizard's in position 0. And we want to say whether or not hasNext is true. Well, in this case, as long as size is 1 or greater and wizard position is 0, we'll return true. And in fact, you could think about it this way. As long as the wizard position is less than the size, then we're good to go. We know that there are more places the wizard can go. And then as far as next goes, remember we have to do two things. We need to advance the pointer, and we also need to return a value. So we could set aside the value, which will be, I guess I'll call it return val, is going to be keys, wizard position. Then we'll have the wizard step forward, and then finally we'll return the return value. And so now at this point, when you create a key iterator, you imagine a wizard appears. That's kind of lame. And then we will step through as follows. As long as the wizard has not gone off the list, then we'll step our way one step by one step until we get to the end. And so now at this point, it should actually just work. Let's try it. So we run it and we get hello, Syrup's Kingdom. Lovely. So if we go back and reflect on what we just did, here is our array map class. It's a little different than the one we just wrote. And here we see an iteration demo. And this little note here is just mentioning that this funny notation, if we're creating a nested class that is not static, we have to have a specific instance. And again, that's because it really wouldn't make any sense if our key iterator was not associated with a particular array. This iterator needs to have access to these values, so this class can't be static, and thus we must instantiate it using a specific instance. So what we'd like to do next is move forward and make it so that instead of this very awkward syntax, right, we want to use the shorthand, we can go as follows and say for string s in AMI system.out.println s. So that's what we want to do, and we're just going to delete all this stuff because that's the shorthand right here. Now, unfortunately, when we do this, we see that we actually get an issue here. Well, partially it's because I misspelled am, just am. But here now I get for each not applicable to this type. So even though our code has indeed the ability to provide iterators, or sorry, even though there exists an iterator class, Java doesn't know how to get to it, right? We don't know, it doesn't know how to instantiate the iterator. And so what we do in this case, we need to make sure that our class has a method called iterator. So let's go in here and say public, we'll say public iterator of, let's say k's. And how do we actually, we have to return it using the iterator method. And to do that now, to get an iterator, well, actually first I'm going to import Java util iterator. It's a little silly. You don't have to import iterable, but you do have to import iterator, as we'll see shortly. But here we have an iterator method. And how do we actually do that? Well, we return a new key iterator. That's all. Okay. So this method returns a key iterator. Let's see. And we are returning a key iterator. Now Java yells at us and it says, I can't do that, right? You need to give me an iterator and you're giving me a key iterator. And the issue here is that we simply haven't told Java that this is an iterator. So we say, okay, hey, by the way, this is an iterator, and it's an iterator over keys. And so at this point, now our class has an iterator method that returns an iterator that does the job. However, iteration demo is still upset, and it says, I don't know. It doesn't know that an iterator method exists. And this is the one place where the shorthand is not quite totally accurate, because Java will refuse to for each through a data structure unless you also say implements the iterable interface. Okay, So basically, this, oops, can't double that, there we go. So it implements both map61v and iterable. And now finally, that we've said that this thing is iterable, gloriously, in iteration demo, it is now happy. Okay. So those are all the steps we had to do in order to make this thing actually iterable. And now if we run it, we can use this nice, short, beautiful shorthand. Okay. So just to maybe summarize what we did there. In order for the shorthand to work, we had to have iterable up here. For iterable to be up here, we had to have this method. Like for example, suppose I delete this method. At this point, it says you claim to be iterable, but you don't have an iterator method. Okay, so I put it back. That's what makes it an iterator. Now, when I return an iterator, I of course need to have this. Say I delete that. Now this function won't compile because it says a key iterator is not an iterator. So make sure you understand the distinction between iterables and iterators. It's a little subtle, but I think it's pretty natural once you understand it. Okay, this is basically just the slide version, the same story we just told. But the punchline now is that our class now, it can be stepped through. Okay, and so at this point we're done, and I'll say the following. If you want something to be iterable, you simply need to say, hey, I'm iterable. And that means you need an iterator method that returns an iterator. That's the short version. Now, one thing that came up actually during live lecture I really liked was, is there some way to do this without creating an inner class? And it turns out, actually, yes, there is a way. So for example, we don't need to make our own iterator class. We're trying to iterate over keys. And so we could do something like list k key list equals keys. And then we could actually just return keylist.iterator. And in that case, well, you know what? We're done, right? Like that's a perfectly lovely iterator. It's a list. It probably has an iterator method of its own, and that avoids the need to build any of that stuff. So this would also work, but I did all these other exercises because you may not actually have some obvious way to do things like that, or easy way to do things like that. It's not obvious. The only last thing I want to say is that this approach will work even if we make this class private. So now I have private class key iterator. And even though all of these things can no longer be accessed by the outside world, that is, you cannot get in a key iterator, this will still work. And it's a really nice thing in Java that we can have in the same way that, I guess the example I used in class today, Grigameth. Grigameth, the character from our earlier lectures and from our midterm this semester, he's a terrifying demon god, right? You can't actually say his name if you're a student without being consumed by flames. However, you can indirectly refer to him as that guy from the exam or whatever, and be safe from being consumed by flames. Just so, even though a key iterator is private, you can still refer to it as an iterator. That is, I could go into the iteration demo and I could say, hey, you know what? I'd like an iterator over strings from my class AM, and I'll say iterator. And let's see, I gotta import util iterator. And so in this case, I can actually get an iterator, even though it is the case that the specific class I'm getting is private, because this public method, it gives us a pointer to this class that I can instantiate. And we'll play around with that a little in the coming lecture. Okay, so that's it for iterators. Sorry, a little bit like janky tangent there at the end, but I still think there's some interesting stuff there, and I'll see you in the next video.